Professional course in English. Process technology. Equipment and systems. Unit 6. Reactors. In this lecture you will learn continuous and batch reactors, stirred tank reactors, fixed bed reactors, fluidized bed reactors, tubular reactors, reaction furnaces, general reactor design considerations. A reactor is a vessel in which a controlled chemical reaction takes place. There are 5 basic types of reactors. Stirred tank reactors, converters, or fixed bed reactors, fluidized bed reactors, tubular reactors, reaction furnaces. There are many other types of reaction vessels. However, most of them are simply combinations of those 5. The various things that have an effect on a chemical reaction are called reaction variables. Temperature, pressure, reaction time, concentration of reactants, catalyst, inhibitors. Exothermic reactions are characterized by a chemical reaction accompanied by the liberation of heat. As the reaction rate increases, the evolution of heat energy increases. Controlling reactant flow rates, removing heat, or providing cooling can control exothermic reactions. Endothermic reactions absorb energy as they proceed. They must have heat added to form the product. Continuous and batch reactors. Industrial manufacturers use 2 basic methods of reactor operation. Batch, continuous. In a batch operation, raw materials are weighed carefully and added to a reactor. The raw materials are mixed and allowed to react. After a predetermined amount of time, the batch is dumped and a new batch is mixed. Continuous reactor operation adds raw materials incrementally to the reactor. Finished products flow out while raw materials flow in and are exposed to catalysts, pressure, liquids, or heat. Stirred tank reactors. A common type of reactor is the mixing, or stirred reactor. The basic components of this device will include a mixer or agitator mounted to a tank. The stirred reactor is designed to mix 2 or more components into a homogeneous mixture. As these components blend together, chemical reactions occur that create a new product. A stirred tank reactor is often referred to as a batch reactor. The basic features of a stirred reactor are designed to provide long reaction times, mechanical agitation, a method of cooling or heating the reaction. Stirred tank reactors are used for liquid-liquid reactions, gas-liquid reactions, liquid-solid reactions, alkylation stirred reactors. Alkylation units take 2 small molecules, isobutane and olefine, propylene, butylenes, or pentalenes, and combine them into one large molecule of high-octane liquid called alkylate. This combining process takes place inside a stirred tank reactor filled with an acid catalyst. Alkylate is a superior anti-knock product that is used in blending gasoline. Fixed-bed reactors. A fixed-bed reactor, often called a converter, is a vessel that contains a mass of small particles, through which the reaction mixture passes. The mass is usually a packed bed of catalyst. As the process medium passes through the catalyst, the reaction occurs. Since the catalyst occupies a fixed position inside the reactor, it is not designed to leave the reactor with the process fluid. Fixed-bed reactors are designed with an inlet line and an outlet line, distribution and support grids, process, and safety systems. Hydrodesulfurization is a process used by industrial manufacturers to remove sulfur. During operation, hydrodesulfurization units use a fired heater, separator, and a fixed-bed reactor. Hydrocracking is a process that industrial manufacturers use to boost gasoline and diesel yields. The process takes heavy gas-oil molecules and splits them into smaller, lighter molecules. During operation, hydrocracking units use a first and second stage fixed-bed reactors, a separator drum, and a fractionating tower. Fluidized bed reactors. A fluidized bed reactor suspends solids by the countercurrent flow of gas from the bottom of the reactor. Over time, particles segregate as heavier components fall to the bottom and lighter ones move to the top. Fluidized bed reactors. Fluid catalytic cracking units take heavy gas oil and split it into smaller, more useful molecules. During operation, fluid catalytic cracking units use a catalyst regenerator, a fluidized bed reactor, and a fractionation tower. Fluid coking is a process used by industrial manufacturers to squeeze every last useful molecule out of heavy residues. Residue from other processes flows into a specially designed, high-temperature fluidized bed reactor. Light products vaporize and flow to a fractionation column. The remaining material is sent to a burner, where further processing takes place. The burner produces three products: coker gas for use in the plant, product coke for sale, and recycled coke for the reactor. Tubular reactors. The design of a tubular reactor can vary from the simple jacketed tube to multi-pass shell and tube reactors. This type of reactor is simply a heat exchanger in which a reaction takes place. Tubular reactors are used for liquid and gaseous reactions. The raw material feed usually must be fairly clean or it may plug the tubes. Because the tubular reactor contains only a small volume of reactants at a given time, it is used only for continuous feed processes. Tubular reactors are needed for chemical synthesis. Reaction furnaces. Reaction furnaces are simply fireboxes containing an arrangement of tubing through which the reactant stream is passed. Most furnaces are used to crack hydrocarbons. However, there are reformer furnaces in which steam and methane are reacted together to get synthesis gas, carbon monoxide and hydrogen. For the catalytic cracking of hydrocarbons, catalytic pellets are packed in the tubes inside the furnace. Reaction furnaces are also used in the olefins and vinyl chloride unit. General reactor design considerations. Besides choosing a type of reactor and the considerations associated with each type, there are certain design considerations that are common to all reactors. These factors include corrosion, safety devices, heating and cooling media. At the operating conditions of some reactors, the reactants or products may be corrosive to the common materials of construction. Tests should be made on the reaction system if corrosion data of the system are not known. Corrosion can contaminate the product, inhibit the reaction, or poison the catalyst. Usually, any reactor or reaction system can have a set of conditions that could cause a hazardous situation. Safety devices such as emergency cooling, fire control systems, and toxic chemical detection systems are available for most hazardous conditions and should be installed as needed. The choice of the method for heating or cooling the reactor must be made in the design phase. The basis for such a decision is concerned with availability of steam, brine, cooling water, and the like. The temperature at which the reaction must be controlled. The cost of each method. To revise the learned material, answer the questions. What is the primary function of a reactor? What are the 5 basic types of reactors? What is an exothermic reaction? What is an endothermic reaction? What is batch operation? What is continuous operation? What is a stirred reactor, often referred to as? Give the example of using a stirred reactor. Give the examples of using fixed bed reactors. Give the examples of using fluidized bed reactors. What types of reactions tubular reactors are used for? Give the examples of using reaction furnaces. What are 3 common factors, which must be considered in the design of reactors? What effects can corrosion have on a reaction? What is the basis for the choice of the method for heating or cooling the reactor?